Hey guys, how you all doing? It's Shalajora here again, back with another video from BHM at GCSE Chem, and today we're going to do section C4.7, which is all about titrations. So that's what it's called. So C4.7, so section C4.7 is called titrations. And this topic is only for GCSE chemistry students only, so only for triple science students only, not for people studying combined science. And so I'll be putting TSS only on the title of the video, I'll be writing that on the title of the video basically. And this is the book I'm using. It's the AQA GCSE Chemistry Revision Guide from Caboodle, and so I've shown that in all videos so far, I'm pretty sure. But so today we're doing C4.7, which is called titrations, and it's a triple science students only topic, so not for students studying combined science. Now, in the last video, actually, I was watching it back. I think I watched it today. Yeah, I watched the video today, and I saw that when I showed you the questions from the last section, which was C4.6, expressing concentrations. That was, I showed it quite blurry, like you couldn't see the questions. So just want to show that now. There you go. I'm not going to be going through the questions again because I obviously went through them in the last video. But there you go. Hopefully you can see the questions more clearly now. And I'm really sorry about not being able to show it clearly yesterday. But yeah, if you're following the student book, it's pages 74 to 75 that you should be on, which is obviously the big textbook. The student book is the red one. This one's also red, but yeah. And I haven't been able to put the links up to the videos from C3.2 to C4.7, including the why should you pick, well, C4.6. I'm making C4.7 today, but I haven't been able to basically, I think it's easier for me just to say I haven't been able to put all the videos from C3.2 onwards, basically, yeah. So the latest video on there is basically, on my website, is basically C3.1, so I'll try and put all of them by today. You know, I'm quite busy, so but I'll try and put all the links to the videos on my website from C3.2 to C4.7. Obviously today I'm doing C4.7 titrations. But without further ado, let's begin. So you can use titrations to find out the exact volumes of acid and alkali that react with each other. So yeah, well, that's very important. So that's what titrations are for, basically. You use them to find exact volumes of acid and alkali that react with each other. And then actually in the next section, C4.8, we're going to actually look at titration calculations. But in this section, we're just going to look at the procedure and one calculation, but a couple of calculations, but yeah. So you can use titrations to find the exact volumes of acid and alkali that react with each other. So that's what titrations are used for. You need to know what a titration is, basically, and that's all you have to say is to find exact volumes of acid and alkali that react with each other. They ask you what is the purpose of a titration for a mark or for 1 mark question or something, and the point at which the acid and alkali have completely reacted is called the end point of a reaction. So basically, if they ask you what the end point of a reaction is you just say it's the point at which acid and alkali have completely reacted together, and say what are titrations used for? Well, they're used to find the exact volumes of acid and alkali that react with each other. So you just need to know these things. And by the way, I'm in my room today again making the video, not in the living room or lounge. I'm in my room today making the video. But as you could probably see, and carrying out a titration. So this is a required practical that you need to know, so I'm just going to go through the 9 steps. So the first step is you use a pipette to measure a known volume of alkali. Put the alkali in so the first step is to use a pipette and you measure the known volume of alkali, and normally this known volume of alkali is 25 cm cubed, and it doesn't even have to be alkali, it could be acid, but it's basically whatever they ask you in the question. You could say alkali or acid. It's basically the known volume always goes in the pipette, and this could be acid or it could be the alkali, and and normally it's actually 25 centimeters cubed of acid or alkali that we put in the pipette, and we use a pipette filler for that actually. to put the 25 cm cube. So that's important as well. Then you put the alkali in a conical flask. So obviously this so this is carrying out a titration required practical, and in this book, obviously they're using alkali as the one in the pipette and the acid in the burette, but it could be the other way around as well, just to make that clear. So let's go through that again. So use a pipette to measure a known volume of alkali. Put the alkali into a conical flask, so that's step 2. And then step 3 is add a few drops of acid-base indicator to the alkali in the conical flask. So basically the acid-base indicator could be either phenolphthalein or methyl orange. So they're the 2 indicators that you normally use at GCSE and I think at A-level as well. Then what you do is step 4 is you fill the burette with acid. Then you record the initial reading on the burette for step 5. Add a small amount of acid to the alkali in the flask, and you mix the solutions, because obviously you've added your alkali in the pipette. Then what you do is you add a few drops of indicator, and so basically you add a few drops of indicator, then you fill the burette with acid, and then you record the initial reading on the burette. So you need to record the initial reading on the burette basically, so that you can measure what volume of the acid was needed to actually neutralize the alkali. So that's what the main part of the main purpose of a titration is. And then you add a small amount of acid to the alkali in the flask, and you mix the solutions. So basically you mix them by maybe stirring them. And then what you do is you for step 7 you repeat step 6 until the indicator changes color. This is the end point of a reaction when the acid and alkali have completely reacted. So basically you're adding your acid to the alkali here, obviously, in this titration process, and whenever you see a color change, that's when that's when the end point of the reaction has been reached. So that's actually when that's when the acid and alkali have obviously completely reacted together. And then step 8, you record the final reading of the burette. And then for the final step, step 9, repeat the whole process at least 3 times. Try to get two results within 0.1 centimeters cubed of each other, which are called concordant results, and take the mean of the 2 results. So normally what you do is you'd carry out a rough titra, which is not a very accurate one. You're very likely that you're going to miss the mark, and you're not going to get the exact value. You're not going to get a very good value for or very precise value for or accurate value for the amount of acid in this case that was neutralized, the volume of acid that was required to neutralize the alkali. But that's why you have to basically carry out the titrations a few times, let's say at least 2 times, until you get keep carrying it out until you get concordant results. And these concordant results are basically results which are within 0.1 centimeters cubed of each other. And if you don't get that, that much accurate, if you don't get to that much, if you don't get results which are 0.1 centimeters cubed of each other, you have to keep repeating it until you get these concordant results. And obviously then you can take the mean of the 2 results, or however many results that are concordant. So say if you've taken 5 results, not all 5 may be concordant. You only take the mean of the concordant results. And in the book it says the concordant results are ones which are within 0.1 centimeters cubed of each other. So you won't, if you've done 5 titrations, you wouldn't, 5 repeats of your experiment, you wouldn't take all 5 if they aren't within 0.1 centimeters cubed of each other. You only take the ones that are 0.1 centimeters cubed of each other, which are known as concordant results, basically. And so here's a question. So which piece of apparatus would you use to measure a fixed volume of solution? So here's one question of actually 2. So if the answer to this question is a pipette, I've told you the known volume of solution, the known volume goes into the pipette. The volume that you're trying to find out goes into the burette. So the answer here, when it says which piece of apparatus would you use to measure a fixed volume of a solution, that should be pipette, because you already know the volume of the solution. And the answer should be pipette. Yes, it is pipette. That's good. What else is it? Yeah. So concentrations of solutions. So now we've done that. Oh, by the way, before I go on to the next part, here's an image of a pipette. Wait, let me see again. Yeah, there we go. So here's. I just want to make sure. Yeah. Here's your pipette. This blue thing. Here's your pipette filler. This thing. So you use a pipette filler to actually add your volume of. In this case, it was alkali to the pipette. So you use a pipette filler for that. And yeah, and that's obviously showing a pipette and a pipette filler. Basically, that's what it is. And then here, you basically have your burette. So this is your burette, and in this case, you are adding your acid. Well, yeah, and in your burette, this is your burette. This is what the burette is, and then on the burette, So if I just show it clearly, because it might not be very clear. Hopefully, you can actually see that burette there. It's very difficult to see, but it's basically that thing there. So the top part is the burette, and below that you have your tap. So I know it's quite difficult to see, but I can't really do anything there, but hopefully you can see that. So here it just says a burette. Use the bottom of the meniscus to read the scale. The reading here is 0.65. So you always use the bottom of the meniscus to read the scale. And you know, that's what you just need to know, really. You use the bottom of the meniscus to read the scale. And here it was. Here you can see the reading. If you look at it carefully, it is about 0.65. It's between 0.6 and 0.7. This reading is about 0.65. And you read from the bottom of the meniscus. Now we're going on to the triple science higher students. Something that's for triple science higher students only. So obviously students doing triple science foundation, you know, they don't need to know this. It's only for triple science students who are doing higher, because I think that's, I'm pretty sure, but check just in case, but it says higher here, so I presume that's what it means. Yeah, so concentrations of solutions is now what we're looking at. So concentrations of solutions are measured in grams per decimeters cubed or moles per decimeters cubed. You can calculate, so you either use grams per decimeters cubed or you use moles per decimeters cubed. Now you can calculate the concentration in moles per decimeters cubed given the mass of a solute in a certain volume. So if we're given the mass of a solute and we're given a certain volume, then we can calculate its concentration in moles per decimeters cubed. Now you can work out the number of moles using the equation that we know before. Number of moles equals mass in grams over the mR. And then you calculate the number of moles in 1 centimeters cubed solution and calculate the number of moles in 1,000 centimeters cubed, 1 dm cubed of solution. I don't think that's very important. I don't think that's, you know, the last 2 points, calculate the number of moles in 1 cm cubed of solution and then calculate the number of moles in 1,000 cm cubed, 1 dm cubed of solution. I don't think that's very important. Just know them. Just know you don't need to worry about them too much, but I would still keep those things in your head. And, you know, just remember them. Yeah, we definitely need to first work out the moles if you're given the mass and the volume, basically. So you can work out the moles by the mass divided by the mR, mass in grams over the mR. mR, again, relative formula mass, comes from adding up all the relative atomic masses of the periodic table of whatever the compound you're using, basically. And it's the top numbers in the periodic table, basically. And I've got my pen and paper because I'm going to do a calculation here as well. So 100 centimeters cubed of, so here's the second question, by the way. 100 centimeters cubed of solution was made using 1.2 grams of lithium hydroxide. Lithium hydroxide, by the way, is LiOH. So that's the formula of lithium hydroxide, LiOH. Now calculate its concentration in moles per decimeters cubed. Now what have we been given? So we've been given LiOH. And, we've been given 1.2 grams. So first what I do is I'd work out the number of moles of LiOH. Well, first I'd work out the MR, actually, of LiOH, so that I can work out the number of moles, because I need to do number of moles equals mass in grams divided by MR, so I'm going to have to work out the MR of LiOH first. And that is actually on the periodic, we get that from the periodic table. So if I look carefully, quickly, if I just, Actually, I don't even need to go to my periodic table here. There's a periodic table in the book. I have a periodic table in my room, by the way, but I don't need to go to that. So lithium has a relative atomic mass of 7. So that would be 7 because it's LiOH. So plus 16 for oxygen, isn't it? Oxygen 16, yeah, plus 1. And what's that? So for hydrogen it's 1, I'm pretty sure. Yeah. So if I add that together, I get 7 plus 16 plus 1 gives me 24. Then, what if I wanted, then I want to work out the number of moles. So here I've just worked out the MR of LiOH. Then, what I want to do is the number of moles equals the mass over the MR. So I'll write the number of moles, so actually, wait, what I'll do is I'll write N of LiOH equals the mass in grams, which is 1.2 grams, over the MR, which we just worked out as 24. And 1.2 divided by 24 is obviously 0.5 mole. Now, hopefully that makes sense, guys. N just means number of moles. So N and then brackets over LiOH would be 1.2 grams. That was given in the question. It said 100 centimeters cubed solution was made using 1.2 grams of lithium hydroxide, LiOH. Calculate its concentration in moles per decimeters cubed. Now we know the number of moles that are there, 0.5 moles or 0.5 moles. So we've also been given volume. So we say 100 centimeters cubed. Now first I'm going to convert that to decimeters cubed. So I'm going to convert that to decimeters cubed. Remember from the last lesson, 1 decimeters cubed equals 1,000 centimeters cubed. So that means if you're going from decimeters cubed to centimeters cubed, you're timesing by 1,000. So if you're going from centimeters cubed back to decimeters cubed, you're actually dividing by 1,000. So we do 100 centimeters cubed divided by 1,000. You know how to divide by 1,000 really. Just move the decimal point 3 places. So think of it as 100.0. So that will basically 100 divided by 1,000 is basically 0.1 dm cubed. So hopefully you know that. And all I'm doing is basically dividing by 1,000 to go from centimeters cubed to decimeters cubed. And obviously if I was to go from decimeters cubed to centimeters cubed, I would be timesing or multiplying by 1,000. And sorry if you can hear any noise in the background, by the way, but yeah, so now we have that. Now we want to calculate the concentration in moles per decimeters cubed. Now we know how many moles we have. Yeah, so that's the 0.5 mole. We've worked out the volume as well, which is obviously 0.1 dm cubed. Well, if you did that, that would give you 5 mole per dm cubed. Or you could this would basically be 5 mole per dm cubed. Here's a 5 mole dm to the minus 3, or you could write it as 5 mole slash dm cubed. It really doesn't matter. But essentially they're the same thing, mole dm to the minus 3 and mole per dm cubed is the same thing. Yeah, because if you want to know also why mole dm cubed, if you want to know that mole dm to the minus 3, by the way, just going through that, is obviously dm to the minus 3 can be written as moles times 1 over dm cubed to the 3. And so we just do moles times 1 over dm cubed to 1 over dm cubed, not dm cubed to the 3. It's 1 moles times 1 over dm cubed. That just gives us mole over dm cubed equals mole divided by dm cubed. So that's basically why you could write it as mole dm to the minus 3 or mole slash dm cubed. So hopefully that makes sense. Just giving a brief explanation of why that is the case. 0.5 over 0.1 anyway is 5. Yes, so it should be 5. It should be 5 moles per dm cubed. The answer. Let me just check that. Actually, they don't give the answer. Do they? No, they don't. They don't give the answer to question 2 of this section, which is the final question of the section, which is quite weird. But I am correct. We've been through it. I don't know why they don't give the answer in this for this question, but there we go. So I am right. It is 5 moles per decimeters cubed. Now I've told you how to get through it. Go through it. And that's basically my working out. If you want to see it again. And this last part was just this last 2 lines were just explaining why moles dm to the -3 is exactly the same as mole divided by dm cubed. So moles divided by dm cubed. Moles/dm cubed. So hopefully that makes sense. And yep, so the synoptic link for this section is obviously the synoptic link. It's not in every section, but for the synoptic link is you can find out more about reactions of acids and bases in topics C5.6 to C5.8. We're going to go through that in chapter 5, obviously, in the next chapter, once we're done with chapter 4. And the keywords in the section were titration, endpoint, and so titration, endpoint, pipette, and burette. So they were the keywords. And so if you just wanna see the question number 2 and also question number 1, basically these are the questions in this section. And there you go. Just give you a final look there. Hopefully you can see that there. All right. And just to finish off, the key points in this section are that a titration is used to measure accurately what volumes of acid and alkali react together completely. We know that. You need to know what titration is used for. Can't really help you much on that. You just need to know that it's to measure accurately the volumes of acid and alkali that are needed to react with each other completely. And yeah, the point at which a reaction and between an acid and an alkali is complete is called the end point of a reaction. So that's the point at which the acid and alkali completely react, and it's known as the end point of the reaction. It's when they've completely reacted, they've completely mixed together and reacted, basically. And you can use an acid and base indicator, acid/base indicator, to show the end point of a reaction between an acid and an alkali. That's another key point. And normally the indicators you use are phenolphthalein, or methyl orange. You need to know about them as well. They're the 2 indicators that you can use. And for higher tier students studying triple science, not for triple foundation students, I'm pretty sure, but I might be wrong, is that you can calculate the concentration of a solution in moles per decimeters cubed given the mass of solute in a certain volume. So we've been through I've been through a question like that in this section. So that's the end of the section, guys. I really hope you found this video helpful, and make sure to share, like, and subscribe. Turn the notification bell on so you're notified and updated when I upload new videos that you can watch. I'll try and put the links up to the videos from C3.2 to C4.7 now, including the why should you pick A-level chemistry video that I made, like, I think 3 days ago now. Yep. So yeah, that's the end of this section, guys. Sorry for any noise. I think there's a noise there in the background. But tomorrow I'll be going through C4.8, which is another triple science topic, and it's about C4.8, which is C4.8 is all about titration calculations. So they're quite fun, actually. So we're going to go through them. And yeah, until then, yeah, have a nice day, guys, and see you tomorrow. Thank you very much.